Okay, so this is just a continuation of the review for the final exam. And we will start off with problem number 5, which is where I left off. That is to assume that adults have IQ scores that are normally distributed with a mean of 100 and a standard deviation of sigma equaling to 20. And we're going to find the probability that a randomly selected adult has an IQ greater than 116. Okay, so in this case, this is problem number 5. And the best way to solve this particular problem would be to create a normal curve. Okay, horizontal axis, and then here's the normal curve. Okay, and of course, we're told that the mean was 100. The standard deviation, sigma, is 20. So the first thing we have to do here is let's say this is what, x equal 116. Well, 116 will be somewhere right here. And if it's greater than 116, that means we need to shade everything to the right, because greater than means everything to the right needs to be shaded. Okay. So with the x value being 116, we need to find out what z is. That means we need to find out what the z score would be. And the way we find that out is this. We do z is equal to x minus mu, and that whole thing's divided by sigma. X minus mu divided by sigma. Right, and I'm going to make that sigma look like a sigma. So here we just substitute the x with the 116 minus mu, that's the mean, that's 100, divided by sigma, which is 20. Now, if we do 116 minus 100, that would be 16. And 16 divided by 20 as a decimal will give us 0.8. And I'm going to carry this out to 2 decimal places. That's going to be 0.80. Okay, and then we use table A-2. And I'm going to go ahead and write this out. To find the area to the left, because that table tells us only the area to the left. And it's a positive z-score, so I need the page that says positive z-scores. And I know this is going to be hard to see, but on your you'll have better tables than what I have here on this screen here. We're going to find 0.8, 0.8, which is right here to the left, and then 0.00 is here. And if I read across and down, that decimal value will be 0.7881. So that means here, the area to the left will be 0.7881. However, I want the area to the right of that. That's that shaded area. So when we're finding the probability that x is greater than 116, we have to do 1 minus this area to the left, which is 0.7881. And what is 1 minus 0.7881? Anyone? Yeah, 0.2119. So this is the area that we're looking for here. So the probability of randomly selecting an adult with an IQ greater than 116 would be 0.2119. Okay. Are there any questions about problem number 5? Okay, problem number 6 deals with the confidence interval of a proportion. A clinical trial tests a method designed to increase the probability of conceiving a girl. In a study, 642 babies were born. In a study, 642 babies were born, and 321 of them were girls. Use the sample data to construct and interpret a 99% confidence interval estimate of the percentage of girls born. Now here we're going to round to 3 decimal places as indicated here in the directions. So let's see what we have here. 642 babies were born, that's your sample size. And 321 of them were girls. So X, which represents the number of successes, is 321. And we're constructing a 99% confidence interval. Okay, and there is a table that I did provide where you have to come up with the Z or the Z critical value with the confidence interval. And I can tell you, with 90% confidence, the 90% confidence interval is usually 1.645 for your critical value. For 95%, that's 1.96, and 99%, it would be 2.575. So 2.575 would be your 99% confidence critical value. And then to find out what p hat is going to be, that's a sample proportion. That's usually x divided by n. So in this case here, if I do x, which is 321, divided by n, which is 642, 321 divided by 642 would be how much? 0.5. And then I need q hat, which is 1 minus p hat. So 1 minus 0.5 would be 0.5 again. And of course, to find the margin of error, which is going to be capital letter E, that's going to be your critical Z value, Z of alpha over 2 times the square root of P hat times Q hat divided by N, which is your sample size. So here, your critical Z value is that 2.575 times the square root of P hat, which is 0.5, times Q hat, that's going to be, again, 0.5, divided by N, that's 642. And all of this can be typed into the calculator. So 2.575 times, and then square root, second x squared for the square root, 0.5 times 0.5 divided by 642. And then press enter. And I'm going to round the margin of error off to 4 decimal places. So this will be 0.508. Okay, so I know what my margin of error is, and I also know what p hat is. From there, I can construct the confidence interval. And the confidence interval for a proportion would be p hat minus e, and that's less than p, and less than p hat plus e. So we substitute p hat with 0.5 minus the margin of error. We found that out to be 0.0508. That'd be less than p and less than 0.5 plus 0.0508. So if I do 0.5 minus 0.0508, that would be, and if I round that off to 3 decimal places, that would be 0.449. And that's less than p and less than, I'll do 0.5 plus 0.0508. That'd be 0.44. I did minus again. That should be plus. Okay. 0.551. All right, so that's my confidence interval. And to interpret this, we can say something like this, that we are 99% confident that, and I'm going to say the true, they say percentage, let's say, yeah, let's say percentage of girls born falls between. Now these are decimals, we need to convert those to a percent, so 0.449 as a percent would be 44.9%, and 0.551 as a percent, 55.1%. Okay, and that's all there is to it. Okay. Are there any questions about problem number 6? Okay. Okay, problem number 7. Okay, in problem number 7, it reads, randomly selected students participated in an experiment to test their ability to determine whether, when 1 minute or 60 seconds has passed. 40 students yielded a sample mean of 59.4 seconds and a sample standard deviation of 10.3 seconds. Construct and interpret a 95% confidence interval estimate of the population mean of all students. Okay, so let's identify what we have here. We have 40 students. That's our sample size of 40. And we have a sample mean, that's X bar, of 59.4 seconds. And a sample standard deviation, that's lowercase s, of 10.3 seconds. And we're constructing a 95% confidence interval estimate. Now we're doing a confidence interval estimate of a population mean. So that means here I need to know this. And CL represents the confidence level. Okay. So in this case here, my alpha level is going to be 1 minus the confidence level. So here I do 1 minus 95% as the decimal will be 0.95. And what's 1 minus 0.95? 0.05. And I also need something else, the degrees of freedom. That's always a sample size minus 1. 39, because n is 40. 40 minus 1 will be 39. So here we're going to be using table A-3 with our alpha level being 0.05. And it's going to be always in two tails since we're dealing with a confidence level or confidence interval. And degrees of freedom is equal to 39. That's going to give us our critical t value. So in this case here, I've got this highlighted area in two tails, and where you have on the right, alpha is equal to 1 minus the confidence level. Now let's see, 39. Well, the closest to 39 will have to be, let's say, 38. And we're going to find 0.05. Yes.
So if it says 39, it was 38 before.
Yeah. Good question. Because I did have a table that had like 39 on it. But in this case, I'll use 38. I'll use the smaller of the 39, which will be 38. So if I use 38 and then 0.05, it will be 2.024. Yeah.
So you wouldn't want us to just take like the two numbers from 38 and 40 and the mean?
Okay, what you can do here, if you want to, let's do this. I got for 38, that's 2.024 plus, and for 40, it was 2.021. If I add those two together and divide by 2, if I round this off to 3 decimal places, it'll be 2.023.
Okay.
Yeah. So in this case, here it'll be 2.023 for your critical t value. I don't think you'll have something like that on your final exam, because pretty much you can just, I'll try to get one where you can easily find out what that critical t value is going to be. So we're going to use 2.023 as our critical t value. Now for the margin of error. To find that out, it'll be t of alpha over 2 times s, which is your standard deviation, divided by the square root of n. And t of alpha over 2 will be 2.023 times s, your standard deviation is 10.3, divided by the square root of n, which is 40. So 2.023 times 10.3 divided by, and then second x squared for the square root, 40. And then hit enter. And if I was to round this off to 3 decimal places, that margin of error will be 3.295. Okay, so now I have my margin of error, and I already know what x bar is. From this, I can construct the confidence interval. So this will be x bar minus e, and that'll be less than mu, and less than x bar plus e. And my x bar in this case is 59.4. Minus the margin of error will be 3.295, and that's less than mu, and less than 59.4 plus 3.295. Now, in this problem, we're going to have to round to 1 decimal place since the mean is only to 1 decimal place. So you always round your limits to the number of decimal places that's similar to the one in your sample mean. So it's to 1 decimal place. So if I did 59.4 minus 3.295, I would get to 1 decimal place. Yeah, 56.1. And that's less than mu and less than. I'm gonna do second and enter. Change this to a plus. That way I won't have to type that over again. To 1 decimal place, that would be 62.7. So if we were to interpret that, that means that we are 95% confident that the true mean for all students who were able to determine when 1 minute has passed falls between 56.1 and 62.7 seconds. Okay. All right. Are there any questions about problem number 7? Okay. Number 8. A survey of 940 households showed that 158 of them used email. Use those sample results to test the claim that more than 15% of households use email. Use a 0.5 significance level. Use the p-value method. So here we have to go through that 8-step procedure for testing the claim about a population proportion, because that's what this is. All right, so in step number 1, we want to write the original claim in symbolic form. And the original claim states that more than 15% of households use email. We're dealing with a percent, so that means we have to use the lowercase p. And of course, it says more than, that means greater than. What's 15% as a decimal? 0.15. That's your original claim. P is greater than 0.15. Now, step number 2 is your opposite of the original claim. What would be the opposite of greater than? Less than, less than or equal to. If it's not greater than, then it must be less than or equal to. So your opposite would be P is less than or equal to 0.15. And then step number 3 is writing the null and the alternative hypothesis. So which one would be the, let's say, which one would be the alternative hypothesis? The one greater than. So it'd be P is greater than 0.15. That's going to be the claim, of course. So that means the null will have to be P is equal to 0.15. Now, step number 4 is our level of significance. So what's the level of significance here in problem number 8? 0.05. All right, now steps 5 and 6 is where we use the graphing calculator. We're going to get the Z value. And also using the TI-84, we're going to get our P value as well. Okay, so here's how we use the graphing calculator. Well, now we need to identify some things here. A survey of 948 households, that's N is 940, 158 of them use email, so that X is going to be 158. Okay, so here we press the stat key. We're going to use our right arrow key to test. And we're going to be selecting number 1, which is a z-test. I'm sorry. One proportion z-test is what we want because it is testing a claim about a proportion. So we need one prop z-test or one proportion z-test. That's menu item number 5. And then press enter. Now, P sub 0, that's going to come from the null hypothesis. That'll be the 0.15, so be 0.15. Then go down to X, which is the number of successes. In this case, 158. That's where it says 158 used in emails. N is the sample size, 940. Now, we look at the alternative hypothesis. That's going to tell us which one we need to highlight. The alternative hypothesis says greater than. So I need to use my right arrow key to highlight the greater than P sub 0. Hit enter, and then go all the way down to calculate, and then hit enter. That will tell me what Z is. And my Z value, I'm going to round this up to 2 decimal places, which is 1.55. And then for the P value, right underneath the Z is a lowercase p. That's your P value. To 3 decimal places, what would that value be? 0.6060. That's your P value. And then step number 7 is our decision rule. And that's always this: if the P value is less than or equal to alpha, your significance level, you reject the null hypothesis. And the P value is 0.060. The level of significance was 0.05. Is 0.060 greater than or less than 0.05? Is greater than. So it does not satisfy the decision rule, so that means we need to fail to reject the null hypothesis. And if we fail to reject the null hypothesis, that means that there's not sufficient evidence to support the claim. Because the claim was the alternative, we failed to reject the null. That means that there is not sufficient evidence to, in this case, support the claim. And that claim was that more than 15% of households use email. Okay. Are there any questions about problem number 8? All right, problem number 9. All right, in problem number 9, it does state that a simple random sample of 25 adults is obtained from a normally distributed population, and each person's red blood cell count in cells per microliter is measured. The sample mean is 5.29 and the sample standard deviation is 0.54. Use the 0.01 significance level to test the claim that the sample is from a population with a mean less than 5.4 and use the p-value method. So in this case, again, we use that 8-step hypothesis testing procedure. We start with the original claim. Now we're dealing with a population mean, so we know we got to use the Greek letter mu. And it says here, it's from a population with a mean less than 5.4, so it'd be less than 5.4. That's how we write that in symbolic form. And then step number 2 is the opposite of the original claim. What would be the opposite of less than? Greater than or equal to 5.4. And then step number 3 is writing the null and the alternative hypothesis here. So which one of these would be my alternative hypothesis? The less than, so it'd be mu is less than 5.4, which is also the claim. So that means that the null means that mu is what? Equal to 5.4. Now, step number 4 is our level of significance. That level of significance is, in this case, 0.01. 0.01. Okay, step 5 and 6, we know we got to use the calculator for this. Let's see what we got. We got a simple random sample of 25 adults. That's your N. Our sample mean, X bar, that was 5.29. Sample standard deviation, that's S, that's going to be 0.54. So from the TI-84, we need to know what T is. So here we press the stat key, go over to test. In this case, we're going to be dealing with the t-test. Let me check. Yeah, t-test. That's number 2. Now we're dealing with stats here, so make sure that stats is highlighted. If it isn't, then you use your right arrow key to put the cursor on top of stats and then press enter. Because all we have is just the summary statistics. Yeah, t-test. All right, mu sub 0, that's from the null hypothesis. That's 5.4. We type that in, then press enter. X bar is the sample mean. That's 5.29. We type that in. And then S sub X, that's your sample standard deviation. That's the 0.54. And then your N, your sample size, that's 25. And now for the mu, it's either going to be not equal to, less than, or greater than. Take a look at your alternative hypothesis here. That will tell you which one to choose. And it's not equal to. So we go to put the cursor on top of not equal to mu sub 0, and then press enter to highlight that. Down arrow to calculate, and then press enter. And your t test statistic, in this case, let's say I want that to 3 decimal places. Right. So your t will be negative 1.019. And step number 6, also from the TI-84. Your p-value, that's the decimal value underneath the t. So here's your p-value. Let's say I want that to, let's say, 4 decimal places. What's your p-value there? 1.1593. And then step number 7 is our decision rule. And that is, if your p-value is less than or equal to alpha, you're going to reject the null hypothesis. P-value is 0.1593. The significance level is 0.01. Is 0.1593 greater than or less than 0.01? Here is greater than. So we need to fail to reject the null hypothesis. And then our concluding statement, using simple non-technical terms. Well, the claim was the alternative hypothesis, but we failed to reject the null hypothesis. That means that there is not sufficient evidence to, in this case, support the claim that the sample is from a population with a mean less than 5.4. Okay. Are there any questions about problem number 9? All right, problem number 10 is dealing with 2 population means here. Data on the weights in pounds of the contents of cans of diet soda versus the contents of cans of the regular version of the soda is summarized below. Assume that the 2 samples are from independent, simple, random samples selected from normally distributed populations, and do not assume that the population standard deviations are equal. Use a 0.05 significance level to test the claim that the contents of cans of diet sodas have weights with a mean that is less than the mean of regular soda. And they're telling you what mu sub 1 is. That's going to be for the diet soda, and mu sub 2 will be for regular soda. So when we write the original claim in symbolic form, That means mu sub 1 would be what? Not equal to.
Not equal.
Well, based on the reading of that last sentence, less than mu sub 2. Because mu sub 1 is going to be the mean for the diet soda. The mu sub 2 is the mean for the regular soda. So mu sub 1 is less than mu sub 2. Step number 2 is the opposite of the original claim.
Greater than or equal to.
Greater than or equal to. So it'd be mu sub 1 is greater than or equal to mu sub 2. And then step 3 is the null and the alternative hypothesis.
The null is equal to or equal.
Yeah, it'll be equal. And your alternative will have to be
The claim.
the claim. Mu sub 1 is less than mu sub 2. And I will put claim in parentheses here. All right. And then step number 4 is our level of significance. That will have to be 0.05. All right, and step 5 and step 6, we're going to get those from the TI-84. So it'll be T is equal to, in this case, since we're dealing with means here. We go to stat, go over to test. All right, and then we're going to select the one that says can't be 2-samp. I think it's a 2-samp. Can't be a 2-samp t-test. Here it is. 2-sample t-test. Because we're dealing with 2 samples here. Okay. And then make sure that stats is highlighted because all you have there is the summary statistics. And then X bar 1. Okay, this is going to be for the first, this one's for the second. X bar 1 is that 0.79429. And then your sample standard deviation of the first, that's this number right here, 0.00449. N1, which is your sample size of the first, that's 35. And then we go over to X bar 2. That's going to be the sample summary statistics for the second one. That'd be 0.81494. Sample standard deviation for the second one, that's 0.00741. And then your sample size for the second is 35. And then hit enter. Now for mu sub 1, look at your alternative hypothesis. And it says less than. You want to make sure that less than mu sub 2 is highlighted. If not, put the cursor on top of it and then press enter. Use your down arrow key. For pooled, it will always be no, so make sure no is highlighted. Use your down arrow key again to go all the way down to calculate, and then press enter. So here's what your T test statistic is going to be.
Negative 14.107.
Right. Okay. Want to make sure everything's in there. So it'd be negative 14 point to 2 decimal places 10. Yeah. and the p-value
There.
0. Now I'm going to write it like this. So let's say here the p-value, your decision rule, is less than or equal to alpha. Reject the null hypothesis. So if I compare those, is 0 less than 0.05? Definitely. So we need to reject the null hypothesis. And then we write our decision rule using simple non-technical terms. If the claim is a null hypothesis and we reject this null hypothesis, that means we have sufficient evidence to support the claim. So there is sufficient evidence to support the claim that the can of diet soda, or I should say the cans of diet soda, have a mean weight that is less than the can for regular soda. Or you can say that the contents of cans of diet sodas have mean weights with a mean that is less than the mean for the regular soda. Okay. All right, are there any questions about problem number 10? Okay, problem number 11. Looks like this. Listed below are the annual data for various years. The data are weights in metric tons of imported lemons and car crash fatality rates per 100,000 population. Use the p-value method. Actually, I'm going to change this to the critical value method. Yeah. So here I want you to use the critical value method instead of the p-value method to determine if there's sufficient evidence to conclude that there is a linear correlation between lemon imports and car crash fatality rates. All right, so in this case here, again, we use that 8-step procedure for that. So in step number 1 is the original claim. And always the original claim is going to be that there is a linear correlation between the two. That means rho is not equal to 0. That's just another way of saying that there is a linear correlation. And now step number 2 is the opposite of the original claim. What would be the opposite of not equal to? Equal to. Meaning that there is no linear correlation between those two. Okay. And then the null and the alternative hypothesis Of course, the null has the equal to sign. The alternative has the not equal to. And that's always going to be the case there with these linear correlation problems. And then with this one, unfortunately, I didn't mention the level of significance, but we're going to use a 0.01 level of significance here. So in this case, alpha is equal to 0.01. Okay. Now here we're going to be using the TI-84 plus calculator to find out what the linear correlation coefficient is. So when we do that, here's our table. Here I'm going to press the stat key, and I'm going to put all of this into a table. So we're going to press number 1 for edit. And if you got stuff in L1 and L2 like I have here, we're going to use the up arrow key to highlight L1 or L2. Press enter, clear, and then enter. I'm going to do the same thing for L1. Highlight L1 using the up arrow key, press clear, and then enter. That clears everything out. The limit imports would go into L1. So here we've got 233, 263, 359, 481, 533. Then I'm going to use my right arrow key to go over to L2. The crash fatality rate, enter those in 15.9, 15.6, 15.5, 15.1, 14.7. Okay, and make sure that you do have the same number of data values in L1 as you do for L2, because those two go with each other. Okay, the next step would be after that, press the stat key, go over to test, use your right arrow key to go over to test, go all the way down to linreg t-test, because this is a linear regression. So we want the menu item that says linreg t-test, and then press enter. Now X list should still be L1, and Y list should still be L2. And now look at your alternative hypothesis. It does say not equal to. So you want to make sure that beta and rho, where that is, that not equal to 0 is highlighted. So put the cursor on not equal to 0 and hit enter. Go all the way down to calculate, and then press enter. Now for the R, you have to go all the way down to the bottom. And let's say I want to round this off to 3 decimal places.
Negative 968.
Yeah. Not negative. Yeah, it's negative. Well, yeah. And step number 6, you're going to be using table A-6 to tell me what that critical value is going to be. Now here, and you're going to have to pull up table A-6 because I don't have that with me. The N, which is the number of paired data values, that's 5. The alpha level is going to be 0.01. So what would be that critical value there? Let me see if I can pull this up here. It's A4.
Is it on like one of the packets or?
It should be under 10-1.
Separate? Oh, okay.
Should be under 10-1.
Okay. So 5 is and 0.01.
No, it can't be.
Well, no, I'm saying for N is 5 and then the 6.
0.01 and N is going to be 5.
Yeah, that's 0.959.
0.959. Okay. So here's that table, A-6. 5 and then 0.01, 0.959. So in this case here, your critical value will be 0.959. Now the decision rule is always going to be this. If the absolute value of R is greater than your critical value, you're going to reject the null hypothesis. And the absolute value of negative 0.968 will have to be positive 0.968. And then we compare that with that critical value of 0.959. Is 0.968 greater than or less than 0.959? Greater than. Okay, so it does satisfy our decision rule for the linear correlation. So that means we need to reject the null hypothesis. And then if we reject the null hypothesis, that's saying that there is sufficient evidence, and I'll say this, that there is sufficient evidence of a linear correlation between lemon imports and crash fatality rates. Okay. Okay. All right, are there any questions about problem number 11? All right. And finally, problem number 12. This deals with the one-way ANOVA. If we use the amounts in millions of dollars grossed by movies in categories with PG, PG-13, and R ratings, we obtain the SPSS analysis of variance results shown below. Use a 0.05 significance level to test the claim that PG movies, PG-13 movies, and R movies have the same mean gross amount. So with a one-way ANOVA, we're dealing with 3 or more different population means. So all you have to do there is just the 8-step procedure. And there's not much math that you have to do here. Now, for the original claim, we're dealing with 3 different means for PG movies, PG-13 movies, and R movies. So the original claim in symbolic form would be mu1 is equal to mu2 is equal to mu3. We're dealing with 3 different movie ratings here. Now, step number 2 would be the opposite of the original claim. What was that?
At least one different.
Right. At least one of the means is different. At least one of the means is different. And then, of course, step number 3 will be your null and alternative hypothesis. Well, of course, your mu sub 1 equals mu sub 2 is equal to mu sub 3. That will be the null hypothesis because it has nothing but equal signs in it. That would mean your opposite, at least one of the means is different, is your alternative. All right, and what would be my level of significance here?
0.05.
0.05. And then step number 5 is just using that output to come up with that F-test statistic. So in this case here, what would be your F-test statistic there?
3.101.
3.101. And then the p-value. You're going to get that p-value from right here, 0.059. Now, step number 7 is that p-value approach. So we say if the p-value is less than or equal to alpha, you reject the null hypothesis. And my p-value was 0.059. My level of significance was 0.05. Is 0.059 greater than or less than 0.05? Here's greater than. So that means I need to fail to reject the null hypothesis. And then step number 8 is our conclusion. Well, the claim was the null hypothesis, but we failed to reject it. So that means there is not sufficient evidence to reject the claim, because the claim was the null hypothesis and we failed to reject it. That, let's say PG movies, PG-13 movies, and R movies have the same mean gross amount. Are there any questions about problem number 12? Or are there any questions about what will be on the final exam on Monday? Okay.